All right, what we're going to do is we're going to review the problems off Quizstar Chapter 3, give you a good review to study for the exam. So, first and foremost, the first problem was 20. A lot of people miss this, but really there's two correct answers. Either D or E could be correct. I know it was marked B. I changed it. Remember, when you try and find empirical formula versus molar mass, remember that the molecular formula is a whole number ratio to the empirical formula. Because remember, when we did the molecular formula, we took the actual molar mass and divided it by the empirical formula molar mass. And then we got the magic number and we multiply it. So, and you know this has to be an even number. It has to be a whole number 1, 2, 3, 4, so, or whatever. So if you look right here, if you calculate the molar mass of this ester, it comes out to be 44. Molar mass, that's going to be 44. You got 2 carbons, 4 hydrogens, and 1 oxygen. It's 44. So the empirical formula molar mass is 44. So the number on the top, the actual molar mass, has to be some multiple of 44 that it goes into evenly. So if you look, it could either be this one, it could be 44 divided by 44 would be 1, or 88 into 44 would be 2. The important thing to remember on the test is if I ask you the difference between an empirical formula and a molecular formula, keep in mind that the molecular formula has to be some whole number ratio compared to the empirical formula. So that was the first one most missed, probably because of the keying issue. 17. Molarity of H2C2O4 solution. If you read this, this is a hard problem actually. It combines a couple of different things. It talks about having 25.72 milliliters of molarity. You see the molarity is going to be a conversion factor as soon as I see that. And they give you milliliters here. This was a challenge problem. I wanted to see what you would do with it. This is a difficult problem. So what they're asking you to do is, first, it's a neutralization reaction, which means that you have an acid and a base producing a salt and a water. So the first thing that you're going to have to do is figure out which ones you're given. They're asking you for molarity, though. The molarity of H2C2O4. Remember that it's going to be moles over liters is equal to molarity. They're already telling you the volume of the solution, so really I can take 0.01250 liters goes down here, ET phone home, and all I need is the moles to find the molarity. Well, how am I going to get moles? Well, if I use that in molarity, then that's a conversion factor, so that means my given has to be 25.75 milliliters of NaOH goes right there, right? The first thing that I would do is convert the milliliters. 1,000 milliliters of NaOH is equal to a liter of NaOH. Then I have a liter of NaOH. Remember, molarity is a conversion factor. So I know that 1 mole, or a molarity, is equal to 0.0995 moles of NaOH. Goes right there. This is a metric conversion. This is just a metric conversion to get 2 liters. This is the molarity. Remember, we learned molarity is a conversion factor, so I have to use it in the grid, and there you go. Now I have moles of NaOH at the top. What time is it? It's time for the turkey. So I look at NaOH coefficients 2. I look at the coefficient of H2C2O4. Coefficient of that is 1. So what I'm going to do is go 2 moles of NaOH goes here, and 1 mole of H2C2O4 goes there. Now, I needed moles of H2C2O4 on the top here. So I stopped my grid right there. That's what I needed. All we did in this problem is take molarity and compare it to our stoichiometry problems to get moles. So as soon as I know I need molarity, I run the grid. I'm going to get an answer for this. And I run the grid, I'm going to get 0.001281 moles of H2C2O4. I'm going to drop that on top, divide that into the volume in liters, and you're going to get E. There should be 1 sig fig added to that. It should be 0.1024, I believe, but it's right there in the neighborhood. Next one. We did this one in class. Remember, percent composition can be used as a double-decker conversion factor. So we assume 100 grams of solution. So we say 50 grams of KOH over 100 grams of solution. Remember, the definition of molarity is moles over liters. So then what do we have to do? First, we have to get rid of grams because I want moles on the top. How am I going to do that? Well, the way I'm going to do that is take the molar mass, 56.11 grams of KOH, is equal to 1 mole of KOH. And what I did right there, fluffy bunny style, is get moles on the upper part of the grid. The last step is I have to get liters of solution on the bottom. Remember, density is a conversion factor I can use to convert grams of solution to volume. So I take 1.52 grams of solution, and then is equal to 1 milliliter of solution, and then finally 1,000 milliliters is equal to a liter. Do the calculations. If you cancel that, cancel the milliliters, you're left with multiplying across, and you get the answer for 23. So that's a setup. You're expected to be able to do that. Next one, 13. It asks you how many grams of Na2C CS3. I think I initially keyed this wrong. The correct answer is B on this one. So if you look when you go to do this, you take two givens. This is basically a limiting reactant, or you're trying to find a theoretical yield here. You have a given, there's one reactant and a second reactant. That means you have to do two grids. So I start out with 88 milliliters, 88.0 milliliters of CS2. First thing I need is I need milliliters of CS2 down here. They gave me the density. 1 milliliter of CS2 is equal to 1.26 grams of CS2. As soon as I have grams, that means I go to molar mass. 76.12 grams of CS2 is equal to 1 mole of CS2. Once I get moles in the upper part of the grid, it's time for the turkey. 3:2 ratio. So I'm going to go 3 moles of CS2 is equal to 2 moles of Na2CS3. And then last but not least, 1 mole of Na2CS3 is equal to 154.18 grams of Na2CS3. And the second grid is taking 3.12 moles of NaOH. And then what do I have to do? Well, I have moles, so I go right to the mole ratio, so I'm starting at a different place. 6:2 ratio. So I say 6 moles of NaOH is equal to 2 moles of Na2CS3. Then I tack on the molar mass. 1 mole of Na2CS3 is equal to 154.10 grams of Na2CS3. Remember, when you have a limiting reactant or you're trying to find theoretical yield, it's almost the same thing. You do two grids. There's two givens for each of the reactants. You run it. The smallest number at the end of both grids is going to be your theoretical yield. In this case, it was B. I know it was originally marked wrong on the Quizstar until I fixed it. There's your solution right there. Key thing, a lot of people got this one wrong, is make sure you're reading problems in AP Chem correctly. Sum of the coefficients. So you have to add all the coefficients together when you go to balance this equation. When you go to balance chemical equations, remember the rules are we balance all the elements first, then H, then O. It makes balancing very simple to do. So if you look right here, I'm going to go I'm going to go eraser, and then I'm going to go Al4C3 plus H2O, arrow Al parentheses OH parentheses CH4. Step 1, you balance all other elements. So I have 4 aluminums here, so I'm going to put 4 aluminums there. I balance aluminum first. I have 3 carbons on this side, so I'm going to put a 3 on that side. And then I'm going to balance H. If I look, I have on this side 4 times 3 is going to be a total of 12 hydrogens on this side from here, and 3 times 4 is going to be 12 hydrogens from that species, which means to get I have 24 hydrogens on that side. I have to put 12 on this side to get the 24 H's there. So that's how I balance that out. Then the reason I always balance oxygen last is because oxygen is in more compounds than anything else. So therefore, what will happen will be it will balance itself 90% of the time. It's completely balanced. The last step I have to take is the coefficients. 1 plus 12 plus 4 plus 3 will be your answer. So that's what you have to look for. That's why I think a lot of you guys got confused. You thought it was, I'm not sure what you thought it was looking for, but that's the balanced equation, and you have to add the coefficients to sum. This one, asking how many chloride ions are there in 1 mole of CaCl2. First thing you have to remember is you always have to look at the ratio, because when they ask you about ions, we did one of these in class, is there's in every 1 mole of this, it means you get 1 mole of Ca2 plus ions and 2 moles of Cl minus ions. The subscripts tell you the number of ions that you get. So it's basically a 1-to-2 ratio and a 1-to-1 ratio from the chemical formula. So you take your given 1 mole of CaCl2, that gets dropped in right here. Then you take the ratio of Cl ions in CaCl2, which happens to be 1-to-2. So you pop that in right there. I'm canceling the moles of CaCl2. And the last step is you use Avogadro's number. Pretty simple. I think the biggest piece that people get confused with is remembering that there's a ratio in CaCl2. You have double the amount of Cl because of the subscript, and that's where that ratio comes from. Next one, how many grams of solute are needed to prepare 250 milliliters of solution? Well, if you remember, I always told you that molarity is a conversion factor. If that's a conversion factor, that means that's going to be your given. So what do? Well, we're going to do a grid. I'm going to take 250 milliliters, but remember I told you in class, if I don't have density, I like to put everything in liters. So I'm going to ET phone home it, change it to liters. If I have liters up here, it means I have to have liters down here. Remember that molarity can be blown up to 2.50 moles in a liter, because that's the definition of molarity. So then I'm going to drop that in right here. Liters of K2Cr2O7 equals 2.50 moles of K2Cr2O7. As soon as I get moles in the upper part of the grid, okay, this doesn't have an equation, it's a conversion, but I need grams of solute. Well, how do I get grams in chemistry? Well, 1 mole of K2Cr2O7 is equal to 294.2 grams of K2Cr2O7. So to get grams of solute, multiply across the top, multiply across the bottom, and you get your answer. The other quick way, a quick solution to do it, is you can always take liters times molarity times molar mass is a quick way to always find grams of solute when you need to make a solution in the chemistry lab. We use it in biotech. So liters times molarity times molar mass, it's the same thing you're almost doing in the grid, is a quick way to find grams of solute anytime you're making a solution. Next one, 13. If you look at 13, I think I did 13, didn't I? I thought I did 13. I did. I swear. It's in there twice. 6 is a combustion reaction. Remember, a combustion reaction steps. First step is you need to find grams of carbon from CO2. It's the first step we have to do here. Second step is to find grams of hydrogen from water. And then you can always find oxygen by using subtraction. So first step, this one's asking you percentage is carbon. So I'm going to take this 0.396 grams of CO2. I know the molar mass of CO2 is 44.01 grams of CO2 is equal to 1 mole of CO2. 1 mole of CO2 has 1 mole of carbon in there. That comes from the chemical formula. Last but not least, 1 mole of carbon is equal to 12.01 grams of carbon. When you multiply that out, you should get 0.108 grams of carbon. That should be your answer at the end of that grid. They're asking you for a percentage in this case. Well, the original sample was 0.150 grams, so 0.150 grams goes on the bottom. I take 0.108 times 100, and that will give you its percent of carbon. That's how you calculate the percent of carbon, right? So when you get the percent of carbon, you could then use it for an empirical formula. Next one, percentage of hydrogen. So how do you do percentage of hydrogen? Well, you take the 0.162 grams of water. So 0.162 grams of water. I'm going to convert water. 18.02 grams of water is going to be equal to 1 mole of water. The ratio in hydrogen to water is 1 mole of water is equal to 2 moles of H's from the chemical formula. 1 mole of H is equal to 1.01 grams of H. So when you run that and you calculate it out, you get okay, and then what you get when you finish is point 0.0182. That's grams of H. So then we go back to the 0.0182 grams. The total sample size from the original part of the problem was 0.150. So we go 0.150 here times 100, and you get the percentage. I believe it's D, 12.1. You'll get 12.1. You get the percent of hydrogen. You have the percent of carbon. If you add those together and subtract it from 100, you get the percent of oxygen, and then it becomes an empirical formula, a molecular formula problem, whatever they're asking you to solve for. What's that? Here's the answer to 12. 12 wasn't missed by that many people, but I have it loaded, so what the heck. If you look, density is a conversion factor. 20 grams of CO2. That's your given, goes right there. Grams of CO2, molar mass is 71, equals 1 mole of CO2. As soon as you get there, the coefficient of CO2 is 6. You're trying to find out PCl, so it's 4. So you see the 6 to 4, there's the turkey. And then you convert it to grams, but they want milliliters. That's where your density comes in. You're going to take your density and drop it in as a conversion factor at the end, and you get the correct solution based on that. So that's problem number 12. Those are the top 11 missed problems on the practice test. Check this over, check your work. On Monday, we're going to go over some of the other stuff, but you should be good to go for the exam on Tuesday. All right? Have a good weekend.